Welcome to Brain Vision.
Okay, so we're doing chapter 37, problem 72. So it says if a 75 watt light bulb emits 3% of the input energy as visible light, and it says the average wavelength here is 550 nanometers. Uniformly in all directions, estimate how many photons per second of visible light will strike the pupil, and the pupil has a diameter of 4 millimeters of the eye, and an observer a length 250 meters away. Okay, so first we can calculate the energy from the light bulb that enters the eye by calculating the intensity at a distance 250 meters away by dividing the power in the visible spectrum by the area of a sphere of radius 250 meters. So how we take that is we take the intensity of the bulb is given by the power emitted over the radius or over the surface area of a sphere of radius 250 meters. So we can then multiply the intensity by the area of the pupil to determine the power entering the eye. So the power entering the eye then is given as the intensity at that distance times pi d squared over 4, which is the radius or the surface area of the pupil. Okay, so if we plug this in together, then we get the power in the eye is given by the power of the bulb over 16 times, I did big D again, so this is little d over L squared. Okay, so now we can divide this power by the energy in a photon to calculate the number of photons entering per second. So PE is given as the joules per second. This is a power. And if we're looking for the number of photons entering per second, which we can call N, if we take PE divided by the energy in a photon, that gives us number of photons. So number of photons per second, which is the right units we want. Okay, so let's take our PE. So PE, or N equals PE over HC over lambda. So this is lambda PE over HC. Plug this in, so lambda P over HC times 16, and then we have D over L squared. So this is everything. And now we can calculate the number of photons per second striking the eye. Okay, so first of all, we have lambda, which is 550 times 10 to the negative 9 meters. And now our power is 75 watts, but it says it only emits 3% as visual light. So this is 0.03 times 75 watts. Okay. And now times d squared, and d was 4 times 10 to the negative 3 meters. Square that. Now on the bottom, we have 16 times h, which is 6.63 times 10 to the negative 34 joule seconds, and then 3 times 10 to the 8 meters per second. And then we have L squared was 250 meters squared. Cool. So we have everything here in SI units, and it all should cancel out to come out, like we said, a number of photons per second. If we plug it all in, we get 1.0 times 10 to the 8 photons per second. Cool.